February 14, 2026. 6:47 a.m. Toretsk sector, eastern Ukraine. 18 drones, 14 kills, 35 minutes. 0 radio signals transmitted. A Russian mechanized column, T-72, B-3 tanks, BMP-2 infantry fighting vehicles, a mobile command post, and 2 ammunition resupply trucks, staged in a tree line 4 kilometers behind the front, preparing for a dawn assault on Ukrainian defensive positions west of Toretsk. They were parked inside what Russian commanders considered the most secure electronic warfare bubble on the entire Donbass front. A Pol-21 system anchored the coverage zone. 3 supplementary Volnorez portable jammers extended the denial field across a 15-kilometer stretch. Every GPS signal within range was corrupted. Every radio-controlled drone frequency was flooded with noise. For 3 weeks, Ukrainian FPV operators in this sector had watched their drones tumble from the sky. Signal links severed mid-flight. Russian infantry had grown bold. They moved in the open. They staged vehicles in clusters. They stopped dispersing. That confidence was about to cost them 14 armored vehicles, an estimated 43 personnel casualties, and roughly $12 million in destroyed equipment. Because Ukrainian engineers had built something the Pol-21 couldn't see, couldn't detect, and couldn't stop. I'm your host at Warfist TV, where we analyze the battles that change wars. Today, we're breaking down one of the most significant tactical adaptations of the entire Ukraine conflict, the combat debut of massed fiber-optic guided FPV drones against a fortified electronic warfare zone. This engagement didn't just destroy a Russian column, it rewrote the rules of drone warfare. Real tactics, real consequences. Warfist TV. Let's start with the battlefield. By late January 2026, the Toretsk sector had become one of the most electronically contested zones in eastern Ukraine. Russian forces, after months of grinding positional warfare, had committed significant electronic warfare assets to support a planned push westward. The objective was straightforward: break through Ukrainian defensive lines along a series of fortified villages and push toward the highway junction that controlled logistics for the entire sector. The centerpiece of Russia's electronic shield was the 8.3 V6 Pol-21, a GPS suppression system originally designed to protect strategic installations from precision-guided munitions. Mounted on a Kamaz truck chassis, the Pol-21 broadcasts interference across GPS L1 and L2 frequency bands, creating a dome of navigational denial extending up to 25 kilometers in radius. Any weapon relying on satellite positioning, guided rockets, loitering munitions, commercial drones using GPS waypoints loses its ability to navigate. Which weapon system proved deadliest in this engagement? A. Fiber-optic FPV drones. B. Traditional radio-linked FPVs. C. Artillery. Drop your answer in the comments. Supplementing the Pol-21, Russian EW teams had deployed 3 Volnorez series jammers, compact man-portable units that target the 900 MHz and 2.4 GHz frequency bands commonly used by commercial and military FPV drone control links. The Volnorez doesn't just jam GPS, it severs the video feed and control signal between a drone and its operator. Without that link, an FPV drone is a dead piece of plastic falling from the sky. Together, these systems created overlapping denial coverage that was, by every conventional measure, devastating to Ukrainian drone operations. Intelligence reports from the 28th Mechanized Brigade, which held this section of the front, indicated that drone sortie effectiveness had dropped by over 80% in the 3 weeks following the Pol-21's deployment. Operators were launching drones that flew less than a kilometer before losing signal. Expensive first-person view platforms, each carrying shape-charge warheads capable of penetrating tank armor, were crashing into empty fields. Russian forces noticed. Intercepted radio communications, later reviewed by Ukrainian signals intelligence, revealed a shift in Russian operational confidence. Vehicle commanders were told the EW umbrella made drone attacks practically impossible. Staging areas that should have been dispersed across several kilometers were compressed into tight formations. Supply trucks parked bumper to bumper. Tanks idled in clusters of 3 and 4. This was exactly the behavior Ukrainian planners were waiting for. The story of how fiber-optic FPV drones reached the Toretsk front begins not in a military factory, but in a network of volunteer engineering workshops scattered across central Ukraine. Since mid-2025, Ukrainian drone developers, many of them civilian engineers who pivoted to defense work, had been experimenting with an elegantly simple concept. Replace the radio control link with a physical wire. The principle isn't new. Wire-guided missiles have existed since the 1950s. The American Tau anti-tank missile, first deployed in Vietnam, trails a thin copper wire that transmits steering commands from the operator to the missile in flight. The concept eliminates the need for a radio link entirely. No radio transmission means nothing to jam. But adapting wire guidance for small FPV drones presented unique challenges. A standard FPV drone weighs between 800 grams and 2 kilograms. It flies at speeds between 80 and 140 kilometers per hour. It needs to transmit high-definition video back to the operator while receiving real-time control inputs, all through a physical tether that can't weigh enough to drag the drone down or snag on terrain features. The solution was fiber optics. A single strand of glass fiber, thinner than a human hair, weighing approximately 1 gram per meter. At a flight distance of 4 to 5 kilometers, the entire spool adds roughly 4 to 5 grams to the drone's weight. Negligible. The fiber transmits video and control data at the speed of light with zero electromagnetic signature. No radio frequency emissions, no signal for a jammer to target, no electronic footprint whatsoever. Stay with me. What happens in the next 35 minutes destroys an entire mechanized column, and Russian electronic warfare couldn't do a single thing about it. Ukrainian engineering teams had been refining the fiber-optic spool mechanism since autumn 2025. The critical innovation was the dispensing system. The fiber unspools from a lightweight canister mounted on the drone's underside, paying out smoothly as the drone flies. Early prototypes had problems. The fiber would tangle, snap under tension during sharp turns, or catch on vegetation at low altitude. By January 2026, after dozens of iterations, the teams had developed a reliable spool that could handle the dynamic flight profiles, FPV combat demands, including aggressive terminal dives onto targets. The 28th Mechanized Brigade's drone platoon received their first batch of 12 fiber-optic FPV units in late January. A second shipment of 8 more arrived February 9th. The operators trained for 4 days on a rear area course, practicing flights with the tethered system. The primary adjustment was psychological. Pilots accustomed to the freedom of radio-linked drones had to account for the fiber's physical presence, planning flight paths that avoided sharp obstacles and maintained smooth spool-out. But the video quality was exceptional, with no radio interference to degrade the signal. Operators reported that the fiber-optic feed was cleaner and more stable than anything they'd experienced on conventional FPV links. By February 12th, the platoon declared operational readiness. Now, they needed a target. Ukrainian intelligence provided one almost immediately. Satellite imagery captured on February 12th and corroborated by a long-range surveillance drone on February 13th revealed the Russian staging area. 14 vehicles were identified in a tree line, 3.8 kilometers behind the Russian forward positions. Thermal signatures indicated active engines. The vehicles were being kept warm, ready for rapid deployment. Pattern analysis suggested a dawn assault was imminent, likely within 24 to 48 hours. The composition was significant. At least 4 T-72B3 main battle tanks, identifiable by their turret profiles and reactive armor configurations. 5 BMP-2 infantry fighting vehicles, each capable of carrying 7 dismounted troops plus a crew of 3. 2 MTLB armored personnel carriers. 1 vehicle tentatively identified as a mobile command post, an R149MA-1 command and staff vehicle, essentially the nervous system of a battalion-level attack. 2 Ural supply trucks, likely loaded with ammunition. The command post was the highest value target. Destroying it wouldn't just kill a vehicle, it would sever communications between the assault force and higher command, collapsing coordination at the moment it mattered most. But the entire staging area sat squarely inside the Pole 21's denial zone. Conventional drones couldn't reach it. HIMARS was an option, but rocket stocks were limited, and the coordinates needed real-time confirmation. Artillery could reach the range, but without drone-corrected fire, accuracy against a tree-line target at nearly 4 kilometers depth would be poor. Fiber-optic drones were the only tool that could deliver precision strikes inside that electronic dead zone. The mission was planned for the early morning of February 14, 2026. First light. Enough ambient illumination for visual targeting, but early enough that Russian crews would likely be at reduced alertness before a planned assault. Drone platoon commander, identified in after-action reports only by his call sign, Fiber, briefed his team on February 13th at 9 p.m. 18 fiber-optic FPV drones would be prepared. Each carried a shaped charge warhead capable of penetrating the top armor of any vehicle in the Russian formation. The assault would be executed in 3 waves of 6 drones each. Wave 1 would target the command post and the nearest tanks. Wave 2 would strike BMPs and the second tank group. Wave 3 would hit remaining vehicles and any targets of opportunity. The launch position was selected with care, a basement in a partially destroyed residential building, 1.2 kilometers behind Ukrainian forward trenches. The building offered overhead concealment from Russian reconnaissance drones, solid walls to mask thermal signatures, and clear sight lines to the east through a collapsed section of roof. 3 operators would fly simultaneously, each controlling 2 drones in sequence. A 4th team member managed fiber spool logistics, ensuring each canister was loaded and ready for rapid relaunch. How many of the 18 fiber-optic drones scored direct hits? A. 8. B. 14. C. 18. The answer comes at the end. February 14th. 6:32 a.m. Temperature -7 Celsius. Light frost on the ground. Visibility moderate. Low clouds. No fog. Fiber gave the order. 6:34 a.m. First wave launches. 6 drones lift from the launch position in pairs, separated by 45-second intervals. The fiber-optic spools begin paying out. Thin glass threads trailing behind each drone as it climbs to 60 meters altitude and banks east toward the Russian tree line. Inside the Pol 21's coverage zone, Russian electronic warfare screens showed nothing. No new radio signals, no drone control frequencies, no GPS-guided threats. The EW operators monitoring the Volnorez units saw clean spectrums. As far as Russia's electronic shield was concerned, the sky was empty. It was not empty. 6:38 a.m. First drone reaches the tree line. The operator, call sign Needle, switches to a shallow dive approach, bleeding altitude while the fiber continues to unspool cleanly from its canister. On his screen, transmitted through 4 kilometers of glass fiber at the speed of light, the feed is razor sharp. He can see individual branches on the trees. He can see the exhaust plume rising from a T-72B3's engine deck. He selects the command vehicle. The R149MA1 is parked between 2 BMPs, its distinctive antenna array clearly visible. This is the kill that matters most. 6:39 a.m. impact. The shaped charge warhead strikes the command vehicle's roof at a near vertical angle, penetrating the thin upper armor and detonating inside the communications compartment. The vehicle erupts from within, a flash of orange followed by a column of dark smoke as electronics, fuel, and ammunition inside cook off simultaneously. Subscribe to Warfist TV if you want to understand how modern warfare actually works, because what happened in the next 30 minutes was a masterclass in precision asymmetric warfare. 12 seconds after the command vehicle's destruction, the second drone of Wave 1 strikes a T-72B3 positioned 15 meters to the north. The shaped charge hits just behind the turret ring, penetrating the engine deck. The tank's autoloader ammunition begins cooking off, a chain reaction that sends the turret spinning skyward in a catastrophic kill. The signature Jack-in-the-Box effect that has defined T-72 losses throughout this war. The third drone targets another T-72B3, striking the turret roof directly above the ammunition carousel. Another catastrophic detonation. 2 tanks destroyed in under 90 seconds. Russian crews are now reacting, but their first instinct reveals the depth of their miscalculation. They scan the radio frequencies for drone control signals. The Volnorez operators crank their jammers to maximum output, flooding every common FPV frequency with broadband noise. It changes nothing. There are no signals to jam. Drones 4, 5, and 6 from Wave 1 reach the target area between 6:40 and 6:43 a.m. Drone 4 hits a BMP-2 that has begun moving, attempting to reverse out of the tree line. The shaped charge strikes the vehicle's left flank, penetrating the thin aluminum hull and detonating inside the troop compartment. The BMP lurches to a stop, smoke pouring from every hatch. Drone 5 targets the second ammunition truck. The Ural is loaded with 152mm howitzer shells destined for forward artillery positions. The fiber-optic FPV strikes the cab, and the detonation triggers a sympathetic explosion in the cargo bed. The blast is enormous. Subsequent satellite imagery shows a crater where the truck stood. Trees within a 30-meter radius are stripped of branches. Drone 6 misses. The operator reports a fiber snag during the terminal dive. The strand caught on a tree branch at the edge of the wood line, jerking the drone off its attack vector. It impacts the ground 2 meters from a BMP-2, damaging the vehicle's tracks but not achieving a kill. 4 clean kills and 1 mission kill from Wave 1. 6:47 a.m. Wave 2 launches. 6 more fiber-optic drones lift from the basement position. The operators rotate, fresh hands on the controls, fresh eyes on the screens. The spool manager loads new canisters with practiced efficiency. Russian forces in the staging area are now in visible panic. Thermal imaging from a Ukrainian surveillance drone orbiting at high altitude outside the Pol-21's effective range captures vehicles attempting to scatter, but the tree line works against them. The same concealment that hid the formation from aerial observation now funnels vehicles onto narrow forest tracks. Tanks and BMPs jostle for position on paths barely wide enough for single-file movement. If you believe tactics win wars, type Warfist TV in the comments. Wave 2 drones arrive over the target between 6:51 and 6:56 a.m. The staging area is now partially obscured by smoke from the burning vehicles, but the fiber-optic video feeds cut through the visual clutter with thermal-assisted targeting. 6:52 a.m. AT-72B3 attempting to reverse down a forest track receives a direct hit to its engine compartment. The tank grinds to a halt, blocking the path for vehicles behind it. This is not accidental. The operators are deliberately targeting vehicles in positions that will create bottlenecks. 6:53 a.m. ABMP-2, trapped behind the disabled tank, takes a shaped charge through its roof hatch. The vehicle burns. 6:54 a.m. The third drone of Wave 2 strikes an MTLB that had managed to reach the eastern edge of the tree line, heading away from the engagement. The warhead penetrates the vehicle's rear armor, disabling the engine and trapping the crew. 6:55 a.m. Another T-72B3, the fourth tank kill of the engagement, takes a direct hit to the turret. The ammunition carousel detonates. Another catastrophic kill. The turret separates from the hull in a column of fire visible from Ukrainian forward positions over 3 kilometers away. 6:56 a.m. The fifth drone of Wave 2 targets ABMP-2 that has stopped moving, its crew apparently having dismounted. The shaped charge strikes the vehicle anyway. The objective is equipment destruction, not just crew casualties. The BMP burns. The sixth drone of Wave 2 experiences a guidance issue. The operator reports degraded video quality in the final 500 meters, possibly from fiber microbending during a sharp course correction. The drone impacts near a Ural supply truck, damaging it but not achieving a confirmed destruction. Later assessment classified this as a probable kill based on sustained fire observed in the vehicle's position. 6:58 a.m. 11 confirmed vehicle kills in 21 minutes, 2 probable additional kills. Russian forces have abandoned any pretense of organized movement. Dismounted infantry are fleeing east on foot through the forest. Vehicle engines are being shut down. Crews are bailing out rather than remaining inside what has become a kill zone with no visible attacker and no electronic warning. Wave 3 launched at 7:02 a.m. The final 6 fiber-optic FPVs targeted remaining vehicles and assessed damaged equipment. 3 scored direct hits. A BMP-2 that had been partially concealed under camouflage netting, an MTLB attempting to tow the damaged T-72B3 from the forest track, and a previously struck vehicle that was reignited to ensure total destruction. 2 drones lost fiber continuity before reaching the target area. 1 achieved a near miss that caused no additional confirmed damage. 7:12 a.m. The last drone of Wave 3 impacts. The engagement is over. Total elapsed time from first launch to final impact: 38 minutes of active flight operations with 35 minutes of combat within the target zone. What would NATO doctrine recommend differently in countering fiber-optic drone threats? Comment your analysis. The silence that followed was, in its own way, as remarkable as the attack itself. Russian electronic warfare systems had been active throughout the entire engagement, broadcasting maximum jamming power across every relevant frequency band. The Pol-21 had maintained its GPS denial dome without interruption. The Volnorez units had saturated drone control frequencies with broadband noise. None of it mattered. Not a single fiber-optic drone was affected by any electronic countermeasure deployed that morning. Ukrainian General Staff reports published February 16th confirmed the following losses inflicted on Russian forces during the Toretsk fiber-optic engagement. 4 T-72, B-3 main battle tanks destroyed, all catastrophic kills with total loss of vehicle and probable crew fatalities. 5 BMP-2 infantry fighting vehicles destroyed, 2 MTLB armored personnel carriers destroyed, 1 confirmed, 1 assessed as mission killed, 1 R-149 MA-1 command and staff vehicle destroyed, 2 Ural supply trucks destroyed, 1 confirmed, 1 probable. Total confirmed vehicle kills 14, total probable 16. Personnel losses were estimated at between 38 and 48 killed or seriously wounded, based on standard crew complements for the destroyed vehicles and observed dismounted infantry casualties from secondary explosions. Equipment value destroyed was assessed at approximately $12 to $15 million, accounting for replacement cost of 4 T-72B3 tanks at roughly $2 million each, 5 BMP-2s, the command vehicle, and associated equipment. The cost of 18 fiber-optic FPV drones, including warheads and fiber-optic spool assemblies, was estimated at under $40,000 total, roughly $2,200 per unit. The cost-exchange ratio exceeded 300 to 1 in Ukraine's favor. Intercepted Russian communications from the hours following the attack revealed chaos at the battalion and brigade level. The assault planned for February 14th was postponed indefinitely. A battalion commander in a transmission captured by Ukrainian signals intelligence demanded to know how drones were operating inside the Pole 21's coverage zone. The EW team's response, also intercepted, was telling. They reported that no drone signals had been detected at any point during the attack. They suggested the losses might have been caused by artillery or loitering munitions, not drones. They were wrong, but their confusion illustrates the fundamental problem fiber-optic systems pose for electronic warfare doctrine. If a weapon produces no electromagnetic signature, existing detection systems are blind to it. The first warning a target receives is the impact itself. OSINT investigators subsequently geolocated the engagement area using satellite imagery published by commercial providers in the days following the attack. Burned scars, vehicle hulks, and the ammunition truck's crater were all consistent with Ukrainian General Staff reporting. Combat footage released by the 28th Mechanized Brigade's media team showed fiber-optic FPV strikes from the operator's perspective, the crystal-clear video feed, the smooth approach through the jamming zone, the final moments before impact. The Toretsk engagement accelerated a trend that had been building throughout the winter of 2025 to 2026. Ukrainian drone production shifted rapidly toward fiber-optic variants. By March 2026, multiple volunteer production networks and at least 2 state-contracted manufacturers were producing fiber-optic FPV kits at scale. The unit cost was falling as production volumes increased and spool manufacturing techniques improved. For Russian electronic warfare doctrine, the implications were severe. The entire conceptual framework of counter-drone operations had been built around the assumption that drones require radio frequency links. Billions of rubles invested in jamming systems, from the massive Pole 21 down to handheld anti-drone guns, were rendered partially obsolete against this new class of weapon. Fiber-optic drones cannot be jammed. They cannot be detected by RF sensors. They cannot be spoofed or hijacked. The only countermeasures that work against fiber-optic FPVs are kinetic, shooting them down with conventional air defense, small arms fire, or interceptor drones. But a drone trailing an invisible glass fiber, flying at 120 kilometers per hour at treetop level, presents an extremely difficult target for any of these systems. Visual detection ranges against small FPV drones are typically under 500 meters. Engagement windows are measured in seconds. This is the new reality. Ukraine doesn't just adapt to Russian countermeasures. Ukraine renders them irrelevant. The Toretsk fiber-optic engagement taught 3 lessons that will echo through military doctrine for decades. First, electronic warfare is not a shield. It is a filter. The Pole 21 and Volnorez systems were effective against RF-dependent threats. They were useless against a threat that simply bypassed the electromagnetic spectrum entirely. Any defensive system built on a single countermeasure principle is vulnerable to circumvention. Russian commanders who treated their EW bubble as an impenetrable dome made a catastrophic assumption. Second, cost asymmetry is the defining equation of modern warfare. 14 armored vehicles worth $12 to $15 million, destroyed by $40,000 worth of fiber-optic drones, a 300-to-1 exchange ratio. This is not sustainable for any military, regardless of industrial base. Russia can produce tanks. It cannot produce them at a rate that offsets losses measured in 300-to-1 cost ratios. Third, innovation velocity wins. The gap between Ukrainian engineers identifying the fiber-optic concept, developing a reliable spool mechanism, field testing prototypes, and deploying combat-ready systems was approximately 5 months. 5 months from concept to 14 confirmed kills against a fortified electronic warfare zone. Bureaucratic procurement systems cannot match this pace. The side that iterates fastest defines the battlefield. Now, the answer to our earlier question: how many of the 18 fiber-optic drones scored direct hits? The answer is B, 14. 14 of 18 drones successfully struck their targets, a 78% hit rate on the first massed fiber-optic combat deployment ever conducted. 2 drones lost fiber continuity before reaching the target zone, 1 suffered a terminal guidance issue from fiber snagging, and 1 experienced a near miss that caused only peripheral damage. For a first-generation system in its operational debut, this hit rate exceeded Ukrainian planners' expectations. 3 questions remain. Was the decision to mass all 18 drones in a single engagement the right choice, or should the platoon have preserved some units for future operations? Could Russian forces have prevented this outcome if they had dispersed their vehicles according to standard doctrine instead of clustering under the EW umbrella's false sense of security? What would you have done differently? As the Ukrainian drone commander or as the Russian battalion commander? Subscribe to Warfist TV, because we break down the battles that textbooks will study for decades. Real tactics, real consequences. Warfist TV. The tree line east of Toretsk is quiet now. 14 burnt-out hulks sit among shattered branches. Turrets blown off their rings, hulls split open by internal detonations. The Pol-21 still broadcasts its jamming signal across the frequencies, filling the airwaves with electronic noise meant to keep the sky safe. But the sky was never the problem. The problem was a glass thread thinner than a human hair, trailing behind a 2-kilogram drone that cost less than a decent laptop. Modern warfare punishes overconfidence without mercy. Stay vigilant